Hello everyone. In previous class, we discussed about the classification of element and periodicity in properties. At first, I discussed about the classification of element. Then I covered the history of development of periodic table. At first, I covered the Duvenier triads. As per the Duvenier triads, all three elements in a triad had similar property, and the atomic mass of middle element of each triad is very close to the arithmetic mean of the other two elements. Your atomic mass of sodium is equal to mean of atomic mass of lithium and potassium. Similarly, I have also covered the triad 2. This is your triad 3. This is the classification of element as per the Duvenier triads. This is your Duvenier triads. Next, I covered the second classification, that is your D-Chan Courteous, or it is also called telluric screw, or it is also called helix. This is the D-Chan Courteous 3D classification. It will look like a cylindrical classification. Next, I covered the Newland octavus. We generally classify the elements as per the notes, song note, that is your sare gama pada nisa. Here I have given the picture of John Newland law of octavus. That is your, this is the table. Next, I covered the Lothar-Meyer arrangement. Here, the elements are arranged in a graph. The graph is plotted between atomic mass, atomic mass in the x-axis and atomic volume in the y-axis. Next, I covered the Mendeleev periodic table. It is the also an important periodic table. In this periodic table, generally the table is uh, six periods and eight column. They are generally called group. They are generally called period and group. The six periods here I have given in the picture. Next year, eight columns are present. They are represented as I, double I, triple I, IV, V, VI, V double I, V triple I. Next, I cover the demerit. I also cover the merits of Mendeleev periodic table. In today class, I will explain about the modern periodic table. And more important periodic table till now, the validity of modern periodic table is significant. This is the modern periodic table. Look at that. This is the diagrammatical representation. This is the table which shows the modern periodic table. If modern periodic table here, also like the Mendeleev periodic table, here also group and periods are present. If you look clearly the modern periodic table, then you can see different periods. Here seven period. The modern periodic table have seven period. Look at that. This is the 1, 2, 3, 4, 5, 6, 7. This is called first period. Next, this is the second period. Next, this is third. This is fourth, fifth, sixth, seventh period. Next, the periodic table I have also, but the 18 columns are considered as that is your 16. First column is said to be one I group. Second column is called double I group. Third column is called triple IB. Fourth IB. Five VB. Six VIB. These are the name of the groups. Seventh column is denoted as V double IB. Remember here the 8th, 9th, 10th. The three column are named as group V triple I. Next, 11 column is called IV. 12 column is considered as double IV. 13 column is called triple IA. 14 IVA. 15 VA. 16 VIA. 17 V double IA. And 18 column, that is called V triple IA. Each next in the bottom also two two rows are present. One is considered as a lanthanide series. Next, the second is considered as actinide series. Actually, the lanthanide series elements, there are 14 elements present in the lanthanide series. This is your starts from cerium to lutetium. Actinide series starts from thorium to lawrencium. Actually, the element present in the lanthanide series are present here. All the 14 elements along with the lanthanium is present in this block. Similarly, actinide series is also having 14 element. These 14 elements are present in this block. Here I can consider as actinide series, and the 14 elements and along with the actinide is present here. The modern periodic table again classified into four blocks. One is your S block. This the group one, group two. That is your IA and double IA is called S block elements. Next, starting from group three to group 12, these elements are called D block elements. Next, 13 to 18, these elements are called P block element. And the lanthanide summary of the modern periodic table, let me discuss clearly by point wise. Before going to the modern periodic table, remember an important point, that is your periodicity. It is an important one mark question in exam. A question will ask what is periodicity, then you can write like this: the periodical repetition of the element with a similar property after certain regular interval, where the elements are arranged in the order of increasing atomic number, is called periodicity. Why the periodicity arises? This is due to the reoccurrence of similar valency cell configuration after certain regular interval. Let me explain this point. Now go to the modern periodic table. If you will think about the second period element, in the second period element, lithium, beryllium, next is your boron, carbon, nitrogen, oxygen, fluorine, neon. These elements are present in the second group. When you will move from left to right, then look at that. Here lithium is metal, next beryllium is again metal, but after moving forward from left to right, boron, you can find boron is the that is your metalloid. Next, carbon, nitrogen, oxygen, fluorine, neon are, they are said to be non-metal. Similarly, again move to the third period. When you come to the first column, then sodium will find the metallic character. What are the properties what are the properties linked to the lithium metal, that is similar with the sodium metal? Because here the, if you will draw the electron configuration of lithium, then you will find 2 1. Similarly, if you will draw the electron configuration of sodium, that is your 2 8 1. Lithium having atomic number 3, sodium having atomic number 11. Look at that, here the valency electron for lithium is 1. Here also the valency electron for sodium is 1. Similarly, if you think about potassium, potassium having also valency electron is also 1. Next, rubidium having also valency electron is 1. If you will see the element present in first column, that is your IA group, then you will see that all the elements having the valency, they have a similarity in the chemical and physical property. So when you start from your journey from lithium to beryllium, then beryllium to boron, carbon, nitrogen, oxygen, the metallic character goes on decreases. That means lithium metal, next beryllium metal, next you will move to the boron. This is a metalloid. Next, all the elements are non-metal. When you will return to the same column, but the period is your 3. Sodium is found. Sodium again metal. Next, magnesium metal. Next, aluminum metal. Next, silicon metalloid. Phosphorus non-metal. Sulfur non-metal. Chlorine non-metal. Argon non-metal. Again, same thing will repeat. That means there is a reoccurrence of the metallic character. If you will move from potassium to calcium, again metal character increases up to metallic character increases up to gallium. Next, metalloid. Next, arsenic metalloid. Next, selenium, bromine, krypton. They are said to be non-metal. That means the metallic character again repeat from the column one, that is your IA group. That means if you move in a particular period, then there is a regular trend whether they will decrease or increase. You can also think about the another physical property like your density. Next, you can think about melting point, boiling point. Then same style you can find there is a regular trend. After starting from left to right, when you will end the same property will found. So there is a repetition of the property after a regular interval. After when you will cover 18 elements, next again first column, uh, when you will cover 18 number group. After covering 18 number group, again you will start your journey from the first group, first column, that is your IA. Same property will find. So there is a reoccurrence of the property, whether melting point, density, or next you can think about atomic volume like this. So here a point is given. The periodicity. Why periodicity arises? Periodicity is arises due to the reoccurrence of similar valency cell configuration. Or you already, I have already seen you. Oh, that is the valence electron is one for group one. That is your IA. So after regular interval, same property will again repeated. So this is said to be periodic cause of the periodicity. Periodicity means the repetition of the element with the similar property after certain regular interval when the elements are arranged in the order of increasing atomic number. I will give a general example. I will give a general example. You know very well about the class timetable. You know very well. Suppose I want to draw a class timetable. Suppose this is your Monday, this is your Tuesday, next this is your Wednesday. Like this, you can write Thursday, Friday, Saturday, like this. When you will cover 1 week, after 1 week again Monday will come. Suppose I will teach you chemistry at 10 that is your AM. Next chemistry will again I will find next Monday. So there is a repetition of the subject. Same subject will come after a week. That means after 7 days we will again repeat the same subject. So this is called repetition. Suppose another teacher take the physics at 11 a.m. At Monday. Suppose ML teacher will take your class at 11 a.m. at Tuesday. Next ML class will must be happen at Tuesday at 11 a.m. So if you will follow the time class timetable, there is a repetition of the subject. The subject will come in a different a few day. That means there is a certain day. After that the subject will again come and the teacher will teach you. Similarly, if you follow the modern periodic table, the same property, the metallic character will repeat after a certain after covering certain number of groups. Suppose think about the lithium. If you think about the lithium, the same chemical property, same physical property will again it will seen in the sodium. When it will seen when it cover beryllium, boron, carbon, nitrogen, oxygen, fluorine. After covering all the element, when you will move to the third period, then sodium will come and the property of the sodium is similar with the property of lithium. So there is a reoccurrence, there is a repetition of the same property. So this is called periodicity. Periodicity means repetition of the element with similar property after certain regular interval. When the elements are arranged in the increasing order of their atomic number, that is called periodicity. But if you think about other periodic table, it may will repeat or not. But in modern periodic table, there is a definite there will definitely repetition. Next, move to the modern period table. Modern period table have different name. You can call the this period table as a modern period table. You can also call this is your long form period table. This is your extend form of period table. Next, you also present this is your bore period table. This is your also present form of the period table. There are different way you can say that this periodic table. As per the principle, generally I can say that the modern periodic table follow a law. The modern periodic table follow a law that is your said to be modern periodic law. Like the mentally predictable. Mentally predictable also follow a law that is your mentally predict law. Similarly, here modern predictable follow a law that is your said to be modern periodic law. As per the modern periodic table, as per the modern periodic law, the physical and chemical property of the element are the periodic function of their atomic mass. The only difference between mentally predictable and modern periodic table is the atomic mass and atomic number. Modern periodic table depends upon the atomic number, but mentally predictable depend upon the atomic mass. Same sentence is written in also modern predictable and also mentally predictable. Mentally predictable, you can say that the physical and chemical property of the element are the periodic function of their atomic mass. You can in mentally predictable, you can say again. I want to repeat. In mentally predictable, you can say that the physical and chemical property of the element are the periodic function of their atomic mass. But in modern periodic table, you can say that the physical and chemical property of the elements are the periodic function of their atomic number. This means the elements are arranged in the element periodic table in the increasing order of their atomic number. Let me see whether they are arranged or not. Look at that. Here, if you move to the helium having atomic number 2, go to the from left to right. No doubt, in the first period, two elements are present. But if you move from, if you think about the first period, that is your uh, one row, that is your you can find hydrogen and helium. Hydrogen having atomic number 1, helium 2. Next, move to the lithium, atomic number 3. Next, move to the beryllium. Here, beryllium having atomic number 4. Next, you can think about boron, atomic number 5. Let me give some hints. Look at that. In the left corner, you will see atomic number of each element. In the right side corner, top right corner, you can see about the electronegativity. This is the atomic symbol of the element. In the bottom of the symbol, you can find the name of the element. In the again bottom, you can find out the atomic mass. All the elements are written in this format, so you can easily find. What is this? This is your atomic. This is your said to be electronegativity. This is your atomic mass. So let me explain. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. Next is your find carbon, atomic number 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. If you will see, then the elements are arranged according to the increasing order of their atomic number. Next, move to the another point. Now I will explain about the feature of the modern periodic table. Actually, if you think about the modern periodic table is consist of how many numbers of period. Already I have covered this. How many numbers of periods present in the modern periodic table and how many numbers of group are present in the modern periodic table. You can say that there are 7 horizontal row, that is called period. That means there are 7 period. that is your 16 group. There are no doubt there are 18 column, and the 18 column are converted into 16 groups. The group VI consists of 3 columns. Next, go to the period. If you think about the period, actually the horizontal rows are called period. Yes or no? The horizontal rows are called period. Next, there are 7 periods. What? 1, 2, 3, 4, 5, 6, and 7. Already I have covered first period, second period, third period, fourth period, fifth period, sixth period, seventh period. If you will think about the first period, suppose I want to ask how many elements are present in the first period, then you can say that there are 2 elements are present in the first period. One is the hydrogen, another is the helium. This is the shortest period among the 7 period. If you will see the 7 period, if you will compare the number of elements present in each period, then you will find that there are only 2 elements are present in the first period. So it is called the shortest period. In exam, sometimes a question will ask which period is called the shortest period. Then your answer is your first period. Next, if you think about the second period, in the second period, the element starts from lithium to and end at neon. There are how many elements are present? That is your 8 elements. 1, 2, next 3, 4, 5, 6, 7, 8. This is your second period. If you think about the third period, then again 8 elements are present starting from sodium to that is your end at argon. If you think about the fourth period, look at that. The fourth period having 18 elements. It having 18 elements starting from that is your potassium to that is your krypton. Potassium, calcium, scandium, titanium, vanadium, chromium, manganese, ferrium, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, krypton. Next, you will think about the rubidium. Sorry, next you think about the group number 5 having also 18 elements. Starting from rubidium to that is your xenon. Here atomic number of rubidium is 37 and xenon is your 54. Here also 18 elements are present like the fourth period. But if you think about the sixth period and seventh period, suppose a question will ask you how many number of element present in the sixth period, then you can say 18 elements. No, this is wrong. Actually, you like the fifth and fourth period, the number of element is not same in the sixth and seventh period. Here, 18 elements are given, starting from cesium, barium, next lanthanum, hafnium, tantalum. Like that, you can think about the radar. This is the 18 elements. But remember, among this, with this 18 element, here also 14 elements are present. So, starting from cerium to that is your lutetium, Lu. Look at that. Here, cesium first, 55, barium 56, lanthanum 57. But if you will see the modern periodic table, hafnium having 72. Then the other atomic numbers are present here. After 57, this is your 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69. That is your 70, 71. All the elements are present here. Here, modern periodic table, there is no space. As a result, they are written in the below of the modern periodic table in a separate series. That is your called lanthanide series. Why these 14 elements are called lanthanide series? Because this series will start after lanthanide, after lanthanum. Remember, lanthanide is a series, lanthanum is an element. Since this series start after the element lanthanum, so it is called lanthanide series. Similarly, since this series, the second series is called actinide. Since the second series start after actinium, so suppose I will ask you how many numbers of element present in the sixth period. You can say that there are 18 elements plus 14, that is 32 elements are present in the sixth period. Similarly, you can say that how many numbers of element present in the seventh period. Then you can say that 18 plus that is your 14. In this block, then it is impossible to write 14 element. All the elements must show their atomic number, electronegativity, atomic mass, full name. It is very difficult. So here also same problem you will find. So the 14 elements are presented below the period table as a lanthanide series. Another 14 is your actinide series. Cesium to barium. Next, sorry. Again, I want to repeat. The sixth period starts from cesium to lanthanum. Then again start from cerium to lutetium. Next, hafnium to radium. Sorry, radon. If you think about the seventh period, then the seventh period starts from francium to actinum. Next, thorium to lawrencium. Next, starts from Rutherfordium to OG. This is the 118 number element. So, suppose a question will ask which period is called as the shortest period. Then your answer is your first period. Suppose I will ask you which period is called longest period. Before the before actually what happened, these elements are not present before. It is just present in few years ago. So before the positioning of these element, there are, if you will saw the longest period, then the answer was sixth period. But now the modern period table is updated. So there are two options. Suppose a question will ask which period is the longest period, then you can say that both sixth and seventh period, because the new elements are already updated in the modern period table. But few years ago, the elements, that means in the seventh period elements are not presented in the modern period table. So the answer was sixth period. But now you cannot say that sixth period is the longest period table. Already the new elements are updated, so you cannot say the sixth period is said to be the longest period. So when a question will ask like this, which period is called the longest period, then the answer is your both sixth and seventh. Then now move to the another points of the periodic table. First period starts, this is the shortest period, already I covered. Second period, 8 elements, lithium to neon, covered. The third period, sodium to argon, already I covered. Next, fourth period, potassium to krypton. Fifth period, Rb to Xc. Sixth period, 32 elements, cesium to radon, including 14 lanthanide element, already I covered. Cerium to lutetium. Next, seventh period also contain 32 element from Fr to Og, including what? Sc to Lr lawrencium. Each period represents the principal quantum number of the valence electron of the respective elements. For example, take lithium. Lithium having 2 1. The valence electron is your present in what? That is your L cell. For L cell, N is equal to 2. So lithium belongs to the second period. Let me explain clearly. Suppose I will take an element. Suppose I will take, suppose magnesium. Suppose a question will ask you magnesium present in which period. Then how you will clear will how you will give the answer. If you draw the electronic configuration of magnesium, already I know how you will draw the electronic configuration by knowing the atomic number. You can clearly draw the electronic configuration by cell, by subcell, by orbital. If you want to draw the electron configuration by according to the cell, then you can write 2 8, that is your again 2. This is your K cell, this is your L cell, this is your M cell. M cell, for M cell n is equal to how much? That is your 3. So you can say that magnesium present in the third orbit, third period. After knowing electronic configuration, after drawing the electronic configuration, you can find the valency electron, and you can again find the valency cell as per the valency electron. So after getting the valency cell, you can find the principal number. After getting the principal quantum number, you can easily say that the element present in the which present in XY Z period. Yes or no? Let me explain another. Take another example. Suppose I want to think about chlorine. Suppose a question will end in which period? Chlorine having atomic number 17. Yes or no? If you will draw the electronic configuration of chlorine, then you can write 287. Here, let me explain. Here you cannot say. No, no, no. Let me read again the point. Each period represents the principal quantum number of the valence electron of the representative respective elements. Uh, it's for the actually this point is applicable to the representative elements. Here I have taken wrongly, that is your chlorine. If you think about the chlorine having 7 electrons in the valency cell. So here yes, yes, me explain. Sorry, sorry. Now our target to find out the period in which chlorine is present. It is clearly explained by the help of electronic configuration. For electronic configuration, you know the atomic number. The atomic number of chlorine is your 17. And draw the electronic configuration 287. Now, this is your K cell, this is your M cell. Look at that. This is your K cell, this is your L cell, this is your M cell. For M cell, N value is your how much? 3. So that means chlorine present in the third period. Clear? Suppose take another example. Oxygen. Let me explain oxygen present in which period. At first, write the atomic number. 8 is the atomic number. Draw the electron configuration 2. That is your 6. That is your K cell, L cell. L for L cell, N value is your 2. The valency electron is present in the L cell. L cell is called valency cell. For valency cell L, N value is your how much? That is your 2. So here we can say that oxygen is present in the second period. Like that, you can able to find the period of the elements. You can find the period of barium. You can find the period of selenium, xenon, radon, like this. You know the atomic number. After knowing the atomic number, you will draw the electron configuration. Then after drawing the electron configuration, you can find the valency electron. After getting the valency electron, you will find the valency cell, and for the valency cell, you will write the principal quantum number, value of n. After getting the value of n, you can easily say that this is the period. Suppose the n value is your 4, you can say that the element is present in the fourth period. If the n value is your 6, you can say that the element is present in the sixth period. Like you can say the period of any element. So this point says what? This point says that each period represents the principal quantum number of the valence electron of the respective element. Here lithium is given. The last electron, that is your valence electron, goes to the n value is your 2, so it is present in the second period. Next, the metallic character of the element decreases along a period from left to right. Already I have covered. Look at that. Here lithium is your, again I want to repeat, here lithium is metal, beryllium is metal, but boron is what? Metalloid. That means metallic character decrease. Next carbon is your non-metal, nitrogen, oxygen, fluorine, and all are non-metal. From left to right, the metal will see the next point. The atoms along the period except the transition element. Similarly, when you will move to from left to right, the atomic size decreases. I will clearly explain about what is the atomic size, what is the ionization energy, what is the electron affinity in the upcoming class. So for this class, you only remember the words and remember slightly. Atomic mass, atomic size decreases along the period from left to right. Ionization energy, electron affinity, electronegativity of the element increases along a period. If you will move from left to right, the ionization energy, electron affinity, electronegativity will increase. I will clearly explain in the upcoming class. This is the feature of the period. Suppose I want to move to the group. How many groups are present? There are 16 groups are present. Actually, there are 18 columns. There are 18 columns, and the 18 columns are considered as included three column. Yes or no? Included three column. Again, I want to show you the fact. Look at that. Your eighth number column, ninth number column, 10th number column combinedly represented as V triple I. So here you can say that the vertical column, actually the vertical column are considered as a group. There are two recommendations. Try to understand. One is the old recommendation, another is the modern recommendation. Actually, as per the old recommendation, the groups are named as IA, double IA, triple IB, IVB, VB, VIB, V double IB, V triple I, IV, I double double IB, B, triple IA, IVA, VA, V, IA, V double IA, V triple IA. Okay, A group. IA, double IA, here triple IA, IVA, B, double IB, triple IB, IVB, IB, V double IB, B, here V triple I. You can remember like this. At first, two A are written, then all are B, double IA, next triple IB. Here not given. IB, double IB. Here not written. After IA, double IA, you can start triple I, no doubt, but the symbol is your B, not A. So serial wise, we can write IA, double IA, triple IB. Next, after finishing the A, sorry, after finishing the B, you will see, look at that, here triple I, V triple I is given. After finishing, you again start the rest B. Look at that. You easily remember. Then all B, then last is your A. Here, what happened? If you think about modern IPAC recommendation. IPAC means what is the full form of IPAC? IPAC means International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. Don't think that this is your idli, upuma, puri, aloo, curry. Aloo in Odia. That is your potato in English. Idli, upuma, puri, aloo, curry. Don't think this. Actually, this meaning is your what? International Union of Pure and Applied Chemistry. This is an organization. As per the organization, international organization, all the things are verified and they are satisfied. So old recommendation, as per the old recommendation of IPAC, these are the group. But if you think about the new IPAC recommendation, then the groups are numbered like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and other number. Column number is equal to group number. So here we can say that the group, that is they are called as B triple I group. If you compare the old recommendation and the new recommendation, then you can say that 8, 9, 10 are combinedly called as. Simply you can say that 8, 9, 10, 8, 9, 10 group are called as, that is your B triple I. If you think about the group, now let me explain group one by one. First is your, look at that, look at the modern periodic table. This is your IA group. This is your what? This is your IA group. First group. This is your hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Hydrogen is a gas. But after, if you exclude hydrogen, the remain is your what? Lithium, sodium, potassium, rubidium, cesium, francium. These are said to be alkali metals. These are said to be alkali metals. Remember why these are said to be alkali metal, I will discuss later. But for this class only remember, except hydrogen, all the elements are considered called as alkali. Alkali element present 7 element, that is your double IA. Then you can find beryllium, magnesium, calcium, strontium, barium, radium. Alkaline, alkaline earth metal. This is said to be alkaline earth metal. Next, the group number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All the elements, yeah, from this position to this position, all the elements are called transition element, transition metal element. That is your called transition metal. This is called boron family. Boron, aluminum, gallium, indium, thallium. Actually, neonium. Maybe this matched or not. 14 group. That is your 14 number column. That is your said to be carbon family. Here, carbon family, carbon, silicon, germanium, lead. These are actually there is a certain trick to remember these elements. Funny tricks. If I will clearly explain in the upcoming class. For this class, only remember the elements. But I will teach you how you will remember the all the element easily, and how can you find the atomic number easily, and which element is present in which period, which column, which group. All the things table and the elements are present like this. I just give some features regarding about the group. This the group number 13 is called boron family. 14 is called carbon family. 15 is your said to be nitrogen family. 16 is oxygen family. 17 is your said to be halogen family. All elements, they are stable, highly stable. They fulfill the octet. All the element present in this group have a stable electron configuration, so they are said to be noble element. These are carbon, boron family, all the family. They are said to be as per the name. This is called boron family because this family, because it starts with the first element, that is your carbon. That is your nitrogen family according to first element nitrogen. Oxygen family for the first element oxygen. Next, halogen family. I will give what is the reason why it is called halogen. Actually, they have also other name. I will later try to understand. This is a group. In the bottom, both lanthanide series and actinide series are present in the third group. So remember, suppose I will ask you which which group is the longest group? Which period is called longest period? Then answer is your sixth and seventh period. But if I will ask which group is considered as the longest group, the answer is your Third group, that is your triple I B group, because it have how many elements? Look at that. Here 14 elements. In the first series 14, second series already I covered this. Yes, I will later you explain why these are the elements. Let me start. Except group 1 and 2 and the helium are called s block element. Why these group elements are called s block element? Later I will explain when I will cover you about the different block, s block, p block, d block. Then I will clearly explain why group 1 and group 2 elements are considered as the s block element. For this class only remember group 1, group are considered as the s block element, but the element present in 13, 14, 15, 16, 17, 18 are called p block element. Why these are called p block element? In the upcoming class I before sometimes I already covered which group is the longest group. The answer is your what? Group number 3, that is your triple IB, not a triple IB. Clear? So lanthan respectively, and then extend the bottom of the periodic table in two different rows, which are called F block element. That is your called inner transition element. Why F block element are called inner transition element? Why D block element are called transition element? Later I will discuss. For this class only remember. Already I have covered group 3 to group 12 elements are called D block element. Next, the element of group BA, that is 15, that is your said to be 15 means that is your which let me see 15, 15, 15. This is your 15, that is your nitrogen family. And 16, 17, let me explain the other name. What is the other name of group 15? Here I have given picogen. The elements are called picogen, which chalcogen means ore forming. Of the first element is your oxygen. Already you know that the ores are generally found in the oxide form. Maximum, mostly they are found in the oxide form. Next, you can think about the ores found in the sulfide form like this. But maximum ores are found in the oxide form. If you think about the 16 group, oxide form, sulfide form, maximum elements are present. Look at that 16. This is your 16. All the ores, maximum ores are found in the oxide form or sulfide form. So this is your said to be ore forming elements, because the source of the elements are maximally found in the ores. So this is your said to be ore forming. So they are this is our called, these elements are called what? That is your chalcogen. The other name of oxygen family are considered as chalcogen. Chalcogen means ore forming. Group 17 elements are called halogen. Why these are said to be halogen element? Halogen element means fluorine, chlorine, bromine, iodine. फालतू क्लास में बोरिंग इंस्ट्रक्टर आता है. I will teach you the funny trick. How will you remember the elements of a group? So group 17 is called halogen. Halogen means sea salt producer. That means let me explain. You know the sea salt, that is your NaCl. The sea water contain NaCl, NaF, NaBr, KBr like this. The sea water, the sea bed contain the salt like NaBr, NaF, NaCl, NaI, Ki like this. And the source of the halogen element, that is your fluorine, chlorine, bromine, iodine, is so halogen means sea salt producer. Next, group 18 elements are called erogens. Next, this is all called red gas, inert gas, zero gas. 18 elements are called that is your noble gas. Why this is why group 18 elements are called noble gas. Noble means what? They have why they are called noble gas? Because they have highly stable, so they are special in all the elements. They are the ideal for by following the electron configuration of such element. All the elements wants to attain such the electron configuration of noble gas element. They are great, so they are said to be noble gas. The group 18 elements are also called inert gas because they are stable. Due to their stability, they do not want to react with other. They are inert. They do not react with other. They are inactive. They do not need any. They do not need any other elements help. They are stable individually, so they are inactive. Since they are inactive, so it is called inert gas. Why the group 18 elements are called rare gas? They are present in very small amount in the atmosphere. Rare means that is your few. They are found in small amount, so they are called rare gas. Why they are said to be zero gas? They are also called zero gas because the valency is your zero. They have no tendency to gain. They have no tendency to loss. They have no tendency to share. They are present alone. So the valency is your zero. So that is your said to be zero gas. Why they are called erosion? Because they are found in the atmosphere. There are many names of group 18 elements. Noble gas, inert gas, rare gas, zero gas, erosion, like this you can call any name. Next point is the element in the same group have the same valency. Obviously, let me explain about the group 1 element. Group 1 element, that is your lithium, sodium, potassium, rubidium, cesium, francium. If you will see, if you will see the electronic configuration of all element, then lithium having valence electron 1, sodium having also valence electron 1, potassium having valence electron, rubidium 1, cesium also 1, francium also 1. All the elements the valence electron is same. Similarly, you can think about second group beta mange calcium santro strontium beta mange car santro bap raji bap ba next bap raji. Then you will see the electron configuration, the valence electron the valence electron number of valence electron is 2, also 2. All the valence electron of all these elements is 2, and this is belongs to group 2. So, as per the point, the element in the same group have the same valency, which is equal to the group number or 8 minus the group number, and therefore exist similar chemical property. Since they have the same valency electron, number of valency electron is same, so the reactivity is also same. Because reactivity completely depends upon the valency electron. Electron is the same, so the reaction is the same. Suppose I want to think about another element, fluorine, chlorine, bromine, iodine. This is your halogen element. Valence electron 7, here also 7, here also 7, here also 7. That is the elements belongs to the halogen family. Here, let me say that here the that is yours. 8 minus 7, that is your 1. So the valency is your what? 1. Clear? In the upcoming class, I will clearly explain how will you find the valency oxidation number like this by knowing the atomic number, atomic mass, everything. Similarly, if you think about the boron, Bal Gangadhar Indian Tilak, boron family, Bal Gangadhar Indian Tilak. Baigan alo gajar in thal. That means boron. Here you can say that boron, Bal Gangadhar, boron gangadhar, baigan alo gajar inthal, boron aluminum gallium indium valence electron, and you will again the mine subtract the valence electron from 8, then you will find the valency. Later I will explain how will you find the valency. uh, Let me cover all the points. The largest group in the that is your third B, 32 element, 14 into 2. The two series present lanthanide actinide, and the 4 element is present in the main period. To bottom, the metallic character goes on what increases. If you think about the period left right, the metallic character goes on decreases. But if you move from top to bottom, metallic character increases. Later I will explain the metallic character, atomic mass, next atomic radius, ionic radius, all the things I will cover in the upcoming class. The ionization energy, electron affinity, electronegativity of all the element decrease down the group. Obviously, the element of group 1, 2, 13, 14, 15, 16, 17, 18 are called normal element or representative element or main group element, because these elements represent to the whole group. I am trying to speak. These are said to be normal element or representative element or main group element. By knowing the electronic configuration of these elements, you can clearly represent the period, which period it will present, which group it will present. You can clearly except hydrogen, all elements of group 1 called what? Alkali metal already metal and react with water, form a alkali or base. That means if you react sodium with water, gives you sodium hydroxide. Sodium hydroxide is a what? Alkali. So alkali what? That is your base. That is your called base. Since all the elements present in group 1 except hydrogen react with water, form a base that is alkali. So this is called alkali metal. Next, another question is your what? Alkaline earth metal. Elements are called alkaline earth metal. Why this is called alkaline earth metal? A question will ask why group 2 elements are called alkaline earth metal. What is your answer? These elements also react with the water, like the group 1. From alkali, your group 2 elements are also react with water to form alkali. But extra thing is your they are found in the earth crust. So the name is your what? Alkaline earth metal. It is related to the earth crust. Earth related to earth crust. Alkaline related to base. Group 1 except hydrogen are called alkali metal because they react with water to form base alkali. Group 2 are called alkaline earth metal. Why? Because group 2 elements react with water, form alkali, and they are found in the earth crust. So this is your said to be alkaline earth metal. Already I covered noble gas, inert gas, rare gas, zero gas, erosion. So this is all about the feature of period and group of the modern periodic table. This is the feature of what? Modern periodic table. This is sufficient for this class. Thank you.